In the depths of the Cold War, two superpowers raced not just for power, but for the stars. While America dreamed of the moon, the Soviet Union stared into the boiling hell of Venus. For nearly 3 decades, the USSR sent probe after probe toward that scorching, poisonous planet. 16 successful missions, dozens of failures, and an obsession that never seemed to fade. Why would any nation pour so much treasure into a world that destroys machines in minutes? This is the story of the Venera program and the Soviets who simply couldn't let go. It begins in 1961, before Gagarin's flight had even faded from world headlines. Soviet engineers looked at Venus and saw something America had overlooked completely. Venus was Earth's twin in size, and scientists believed it might harbor similar conditions. Some even imagined jungles, oceans, or swamps hiding beneath those thick yellow clouds. The Soviet leadership saw an opportunity to claim a scientific first before the Americans could. If they couldn't win every moon milestone, they could dominate the mysterious planet next door.
In February 1961, the Soviets launched Venera 1, humanity's first attempt to reach another planet.
Communication was lost just days into the flight, but the ambition had been set in motion. Undeterred, Soviet scientists doubled down, treating failure as simply the cost of pioneering. Venera 2 and Venera 3 followed, both ending in silence, telemetry gone, missions incomplete. Venera 3 did manage one grim milestone, crashing into Venus, the first human object to arrive. It arrived dead, but it arrived, and for Soviet planners, that mattered enormously. Each failure taught brutal lessons about a planet far harsher than anyone had imagined. Western scientists began to suspect Venus's surface was not a paradise, but a furnace. Radio telescope data hinted at temperatures hot enough to melt lead on the surface. Still, Soviet engineers refused to abandon the project, driven by pride and pure curiosity. In 1967, Venera 4 became the first probe to transmit data from another planet's atmosphere. It parachuted downward, measuring pressure and temperature as it descended into the unknown. The numbers were staggering, atmospheric pressure crushing far beyond anything engineers had prepared for. Venera 4's hull imploded before reaching the surface, unable to withstand the punishing conditions. Yet Soviet scientists celebrated because for the first time, real Venusian data reached Earth. It confirmed a planet cloaked in carbon dioxide, hostile beyond anyone's darkest predictions. Rather than retreat, Moscow's space program treated this discovery as a design challenge to conquer. Engineers at the Lavochkin Design Bureau began reinforcing every capsule for the next attempt. Venera 5 and Venera 6 launched in 1969, tougher, heavier, built to survive longer. Both still failed before touchdown, crushed by pressure nearly 100 times that of Earth. Each mission's wreckage taught the next generation of engineers precisely what needed strengthening. Scientists joked bitterly that Venus was where good spacecraft went to die. But quitting meant surrendering scientific glory to a Western world already celebrating Apollo's moon landings. In December 1970, Venera 7 finally achieved what seemed nearly impossible for a machine. It survived descent and transmitted data directly from the surface of Venus itself. For 23 minutes, A spacecraft functioned on a world hot enough to melt zinc. The temperature reading, 475 degrees Celsius, stunned scientists worldwide. Humanity finally understood Venus was no twin paradise, but a genuine vision of hell. Soviet propaganda seized the victory instantly, broadcasting it as proof of technological supremacy. Yet privately, engineers knew survival for mere minutes wasn't nearly good enough. They wanted photographs, chemical samples, real evidence of a world no human would ever visit. It revealed Venus's daylight resembled an overcast day on Earth, dim beneath thick clouds. Soviet designers realized cameras could actually work if they solved cooling and power problems. This ignited a new, even more ambitious goal: capturing the first photograph from another planet. Engineers built specialized titanium spheres designed to resist crushing pressure for longer periods. Cooling systems used pre-chilled internal components, buying precious extra minutes on the surface. In 1975, twin probes Venera 9 and Venera 10 launched toward their fiery destination. Both successfully landed, and both accomplished something no spacecraft had ever done before. They transmitted the first images ever captured from the surface of another planet. Grainy black and white photographs revealed jagged rocks scattered across a barren, alien landscape. Newspapers worldwide printed those images, marveling at humanity's first true glimpse of Venus. For the Soviet Union, this was a propaganda triumph, rivaling any American moon photograph. It proved their persistence through nearly 15 years of catastrophic failures had finally paid off. But triumph only fueled greater appetite. Now they wanted color, chemistry, and closer analysis. Venera 11 and Venera 12 launched in 1978, carrying instruments to analyze atmospheric chemistry. They detected lightning storms raging within Venus's dense, sulfuric, acid-laden clouds. Unexpectedly, their cameras failed due to a design flaw, denying the promised color images. Frustrated engineers vowed the next mission would finally deliver true color photography from Venus. In 1981, Venera 13 and Venera 14 finally succeeded where earlier missions had stumbled. They transmitted the first color photographs ever taken from the surface of another world. Images revealed an orange-tinted landscape, flat volcanic rock beneath a hazy, oppressive sky.
Venera 13 survived over 2 hours, an eternity given the planet's murderous environment.
Its instruments drilled into the soil, analyzing composition never before measured directly on Venus. Results showed basaltic rock, suggesting ancient volcanic activity had shaped the entire surface. Soviet scientists now possessed more direct data about Venus than any nation on Earth. Still, the program pressed forward, refusing to consider its Venus ambitions complete. In 1983, Venera 15 and Venera 16 shifted strategy, orbiting rather than landing. Using radar, they mapped Venus's northern hemisphere, hidden beneath its impenetrable cloud cover. These maps revealed mountains, craters, and volcanic features invisible to ordinary optical telescopes. It was a scientific leap forward, proving orbital radar could unveil a hidden world. By the mid-1980s, the Soviets combined Venus exploration with an entirely new opportunity. Halley's Comet was approaching, offering a rare chance to study it during its brief visit. Soviet engineers designed the Vega missions to use Venus as a gravitational stepping stone. Vega 1 and Vega 2 launched in 1984, carrying landers and revolutionary floating balloons. Each spacecraft dropped a lander on Venus before continuing onward toward the distant comet. For the first time, balloons drifted through Venus's atmosphere, riding violent, high-altitude winds. These balloons revealed turbulent weather patterns scientists had never directly observed before.
After releasing their landers, both Vega spacecraft continued their journey toward Halley's Comet.
They successfully photographed the comet's nucleus, a historic achievement in international cooperation. The Vega missions represented the pinnacle of Soviet planetary engineering and scientific ambition. Yet even here, Venus remained central, a stepping stone rather than an afterthought. So why exactly couldn't the Soviets simply let go of this brutal, unforgiving planet? Part of the answer lies in raw scientific curiosity about a world so alien. Venus offered mysteries no other planet could match. Extreme heat, crushing pressure, acid clouds. Understanding it meant understanding planetary evolution, climate extremes, and possibly Earth's distant future. Some scientists feared Venus represented a runaway greenhouse effect, a warning for our own world. Studying its atmosphere offered clues about how planets could spiral into permanent hostility. This scientific motivation alone justified enormous investment, despite repeated technical heartbreak. But ideology mattered just as much as pure scientific inquiry throughout the entire program. Every Venera success became powerful propaganda, proof that Soviet technology could conquer any frontier. While America owned the moon narrative, Venus became distinctly, unmistakably Soviet territory. Losing that narrative would have meant conceding another symbolic battlefield to the West.
National pride, therefore, became inseparable from every design decision made by Soviet engineers.
There was also a simpler, more human explanation behind this relentless persistence. Soviet scientists and engineers had invested their entire careers into solving Venus's brutal puzzle. Walking away after each failure meant abandoning years of accumulated knowledge and sacrifice. Every crushed capsule taught something new, making the next mission's success feel closer. Sunk cost became scientific momentum, each disaster reframed as a necessary stepping stone forward. The Lavochkin Design Bureau essentially built its entire identity around conquering this hostile planet.
Abandoning Venus would have meant abandoning decades of institutional purpose and specialized expertise.
Meanwhile, America largely focused elsewhere, prioritizing Mars as its primary planetary exploration target. Mars seemed more hospitable, more relatable, a place future astronauts might someday actually walk. This division of interest meant Venus essentially became the Soviets' uncontested scientific domain.
Why compete directly with America on Mars when total Venus dominance was achievable instead?
This strategic thinking shaped Soviet space policy for nearly 3 decades of continuous effort.
Even Cold War tensions occasionally paused for genuine scientific curiosity to shine through.
Western scientists eagerly studied every piece of data the Soviets published from Venera missions.
In many ways, Venus exploration became one of the era's most successful science exchanges.
Despite political rivalry, planetary science transcended borders when first-hand data proved genuinely invaluable. The technical challenges themselves pushed Soviet engineering to remarkable, unprecedented achievements.
Building spacecraft to survive 900 degrees Fahrenheit required entirely novel material science. Pressure equivalent to nearly a kilometer underwater demanded revolutionary structural engineering solutions.
Solving these problems advanced Soviet material science far beyond what Venus exploration alone required. Many innovations later found applications in entirely unrelated Soviet industrial and military projects.
This ripple effect made Venus exploration valuable well beyond its immediate scientific returns.
By the late 1980s, though, the Soviet Union itself began facing existential internal pressures. Economic strain, political upheaval, and shifting priorities slowly starved the space program of funding.
The ambitious Vesta mission, planned as Venera's successor, was eventually cancelled before launch.
As the Soviet Union collapsed in 1991, so too did its singular focus on Venus. Russia's space program shifted attention toward international cooperation and the emerging space station era. No nation has successfully landed another spacecraft on Venus since those final Soviet missions.
For over 3 decades, humanity's only direct surface data still comes from Venera and Vega.
This makes the Soviet achievement even more remarkable when viewed through modern eyes.
NASA and other agencies have sent orbiters, but landing remains an extraordinarily difficult challenge. Modern engineers still study Venera's designs when planning potential future Venus surface missions. Some scientists argue Venus deserves renewed attention, especially regarding possible atmospheric signs of life. In 2020, researchers detected phosphine gas in Venus's clouds, reigniting worldwide scientific interest.
Suddenly, the planet Soviets refused to abandon became relevant again to modern astrobiology.
NASA and other space agencies have since announced new missions targeting Venus once more. It seems history's persistent Soviet obsession may finally find renewed international validation and continuation.
Looking back, the Venera program stands as one of history's most underappreciated engineering triumphs. 16 successful missions against a planet actively trying to destroy every machine sent there.
Each failure refined the next design, turning catastrophe into cumulative scientific and technical progress.
The Soviets treated Venus not as an obstacle, but as a puzzle worth any cost.
Their persistence reflected a uniquely Soviet blend of ideology, curiosity, and stubborn national pride. While the world remembers Apollo's footprints, fewer recall Venera's photographs from an alien inferno. Yet those grainy images represent an equally profound triumph of human ingenuity and determination. They proved that even hell itself could eventually yield its secrets to persistent inquiry. The Soviets couldn't let go of Venus, because letting go meant admitting total defeat.
Every mission, successful or not, reinforced a narrative of resilience against impossible odds. In many ways, Venus became a mirror reflecting the Soviet Union's own defiant character. Harsh, unforgiving, resistant to change, yet ultimately yielding to sustained, determined pressure. The program's engineers became unlikely heroes, solving problems no one had ever faced before. Their names remain far less famous than Gagarin's, yet their achievements proved equally significant.
Modern planetary scientists still reference Venera data when studying extreme atmospheric conditions today.
The lessons learned continue shaping spacecraft materials, thermal protection, and pressure vessel design.
Venus taught humanity that persistence, even against repeated catastrophic failure, eventually yields genuine breakthroughs. It also taught something darker, that runaway climate change can transform a world entirely. Some scientists still wonder whether Venus once had oceans before becoming this scorching wasteland.
If true, its transformation offers a sobering warning humanity cannot afford to ignore. Perhaps that is the deepest reason the Soviets truly couldn't let go of Venus. It wasn't just about propaganda, pride, or scientific curiosity alone driving their persistence forward.
It was about understanding a planetary catastrophe that could theoretically happen to any world. In chasing Venus's secrets, Soviet scientists were ultimately searching for answers about Earth's own future. And that pursuit, born from Cold War rivalry, still shapes planetary science being conducted today.